Hello dear students, in today's topic we are going to discuss thermometry. Thermometry is a very fundamental, very basic topic and very easy also, but at the same time let me tell you it's very important as well. Important for your NEET exam, and moreover without getting the knowledge of thermometry you cannot excel in heat and thermodynamics. As I told you, this is the very fundamental. So even if you know, there must be all the key points, they must be in your mind, because key points are very fundamental and very conceptual. So let's start with the basic discussion of thermometry. The very first thing that we are going to discuss is the heat and thermodynamics we are dealing with, and we are starting with the definition of heat. What is heat? See, the energy due to the random motion of molecules and random motion of intermolecules, atoms inside the body, that we often call that energy as internal energy. But some part of that internal energy is due to the random motion of the intermolecules, atoms and all, and some part of that energy that is being exchanged because of the temperature difference. That energy, here important point is that exchanged energy. Heat is always exchanged. When you are saying stored energy, that is internal. When you are saying exchanged energy, that is heat. And that exchange due to temperature difference, that's called heat energy. Part of internal energy, this is part of internal energy, that is transferred due to temperature difference is called heat. So it's an energy. Part of internal energy is obviously energy. It is a scalar quantity. Its SI unit is joule, but we use practical unit that we use is called calorie. This is, you can say this is practical unit. What is practical unit? What is 1 calorie? It is the heat, obviously, required to raise temperature of 1 gram by 1 degree Celsius, and preferably in the range of 14.5 to 15.5. So 1 calorie is the heat to raise temperature of 1 gram by 1 degree Celsius, and preferably in the range of 14.5 to 15.5. This is the definition of calorie. Now, next important point for heat, the definition and formula of heat that you have to study in calorimetry. Here we are discussing the very fundamental concepts about heat in thermometry. What is this J equal to W by K? Here a very interesting concept. W, that is work we called, this is basically what you can see, this is basically what? Mechanical energy transfer. And Q is obviously the thermal energy. Q is the, you can see here, thermal energy. So mechanical energy can be converted into thermal energy and thermal energy into mechanical energy by a conversion factor that is called J, Joule's mechanical equivalent. What is the name for this? Name is Joule's mechanical equivalent. Mechanical equivalent. And its value is 4.2 joule per calorie. Means if heat of 1 calorie is there and that is being converted into mechanical energy, that is called work, you will get 4.2 joule of work. So 1 calorie is 4 joule, or 1 joule is 1 upon 4.2, okay, in calorie. Here one important thing you can see, you can make note for this is, work is transfer of mechanical energy irrespective of temperature difference. A very important point. When mechanical energy is getting transferred, temperature difference doesn't matter, irrespective of temperature difference. But when heat is transferred in thermal energy, heat is transfer of, what is heat? Transfer of thermal energy, but that transfer is due to temperature difference. So W and Q interchangeable, but when heat is being converted into W, temperature difference does matter. But when W is converted into Q, temperature difference doesn't matter. This is a very important question for assertion region type or for conceptual objective questions. Next is heat loss or gained depends upon path taken up. Means simply heat is not a point dependent phenomena. It's not like, okay, this point, heat energy changes depending upon the initial and final points. No. Heat change is depending, it's a path dependent quantity, and depending upon the entire process that according to which that has taken up there, according to which the heat has changed. Moreover, if you will think some interesting examples for this, like we have discussed, irrespective of temperature difference mechanical energy, like suppose there is a water in some flask and you are stirring it like this, okay, or some liquid or some gas, some liquid precisely, they are compressed. When they will be compressed, the temperature will rise. Here what we are doing, we are not actually supplying heat, we are doing work, but mechanical work there is the, so like you are steering, you are supplying rotational energy, steering. That mechanical energy is the source of heat there. Okay, so for that what you have done, you didn't change the temperature, you just steering the flask and heat energy was transferred, and because of that temperature rise, temperature increased. Why it increased? Because work was a source of heat energy, but did you change the temperature? You didn't. So do remember, work done, mechanical energy, heat conversion does not depend upon temperature, but heat to work, that depends upon temperature. So after heat, we will now try to define temperature. What is temperature? There are two definitions. One is according to the classical physics, when the intermolecular, the quantum nature was not explored. According to that, we can say that temperature is, it is degree measure of hotness and coldness. Degree measure of hotness or coldness. Degree measure, how hot something, how cold something, that was called temperature. But when KTG came, kinetic theory of gases, and on quantum level, on molecular level, the temperature was explored, discussed. According to that, we can say, or these two definitions are not mutually exclusive, they are equally true. One is based upon the external conditions, second is based upon the intermolecular theory. That is called temperature is the degree measure of kinetic energy of intermolecules. Kinetic energy of intermolecules. This is called temperature. Basically in KTG we know that kinetic energy is equal to 3 by 2 RT or KT depending upon molecular moles. So basically kinetic energy is depending upon temperature. This is proportional to temperature. So higher is the temperature, greater is the temperature, we can say with speedy intermolecular motion is there. That is according to the intermolecular microscopic study. Okay, so these are the basic two definitions of temperature. Again, temperature is fundamental quantity. We can write one of the 7 fundamental quantity. You have read this unit dimension, one of the 7 fundamental quantities. Okay, next one is, unit we know is Kelvin. Generally we measure this in Kelvin, and one Kelvin is defined as 0 Kelvin. That is the absolute zero. Basically what happens with temperature, if you want to increase the temperature, you can increase it till infinity. Practically till now 10 raised to power 8 Kelvin have been found that can be created in lab, we think that. But when it comes to lower the temperature, lower it, you cannot lower it to the any value you want. There is a critical limit for lowering the temperature, and that is called absolute zero. We cannot actually lower temperature beyond that. Although in lab we say that 10 raised to minus 8 Kelvin is possible, but practically lowering temperature below 0 Kelvin is not possible. So when we talk about 0 Kelvin, This is the lowest temperature and also known as absolute zero. Absolute zero. Hence the name 0 Kelvin, lowest temperature, absolute zero. You cannot lower temperature beyond that. Next point is for temperature. In thermal equilibrium, temperature is equal. In thermal equilibrium, zeroth law is this. When we talk about thermal equilibrium, we say that in thermal equilibrium, temperature is what? Constant. Temperature is not changing, temperature is constant. So this is the case of thermal equilibrium. More about temperature is point like how to measure it. How to measure it. And the branch that deals with the measurement temperature, that is called thermometry, and device that is we use to measure it, that is called thermometer. So basically for temperature measurement, what we have to study, what we have to discuss is thermometry and thermometer. Now we will start with the measurement of temperature. See, there are two types of measurement, two types of theory. In classical physics, the temperature was observed from outside, and we can say that under atmospheric pressure. So we never changed pressure in classical physics to measure temperature. So the scale that was prepared in the classical physics was not according to the pressure difference. There the two fixed point theory were used. One fixed point, the lower fixed point, LFP, that we call the melting point also, this, and upper fixed point, the boiling point. And two fixed point theory, they were made as a reference, lower fixed point, upper fixed point, and gap between them, that gap was divided equally, number of equal divisions, and each division was called degree. You say na, degree Celsius. That degree is the one division. So gap between the LFP, the lower fixed point, UFP, upper fixed point, that was divided equally, and that one division is called, that is called 1 degree. So total you can see the 5 scales are there. Celsius, symbol is this, degree Celsius. LFP 0 degree Celsius, upper fixed point 100, and we can say number of division is 100. Okay. So if we want to measure a temperature, in each scale we can write, in each scale 1 degree, the one division, that remains constant. So if we write a temperature, certain temperature, say that is C. So in C, Celsius, temperature is C. What is the gap between LFP? Temperature minus LFP divided by total number of division, and that is 100. Okay. This is called 1 degree. Similarly, when you will go to the Fahrenheit, in Fahrenheit, F minus lower division is 32 and upper is this 212. So what is the number of divisions? LFP, UFP subtraction, and that would be 180. So this is the 1 degree in Fahrenheit, this is the 1 degree in Celsius. Similarly, when you will see in Reamer scale, what is the LFP there? 0 degree. So you will do R minus 0. And what is the gap? Obviously 80 in Reamer. Okay. So that is 1 degree in Reamer. You can see here that the gap is 80. Again, in Rankine, when you will come, in Rankine, what is the temperature? LFP 460. What you will write? You will write Rankine, say RA minus 460. And what is the number of division there? 212. 212. Similarly, equal to when you will come to Kelvin. What is the LFP in Kelvin? 273.15. And what is the total number of division? 100. Okay. So basically 1 degree in each temperature scale is constant. So if you have to relate to temperature in two different scales, first you can either memorize the formula, or if you want to memorize with understanding, the understanding is 1 degree remains constant, and this 1 degree remains constant, this is question in itself. What is the fundamental of what is the basis of temperature scale? 1 degree is constant in each scale. So how to calculate 1 degree? Any temperature minus LFP divided by total number of division. Any temperature minus LFP divided by the total number of division, that is given here. You can see in Celsius and in Kelvin the total number of divisions are same. If total number of divisions are same, then temperature difference will also be same. So in Celsius or in Kelvin, the difference in temperature are always equal. Temperature are not equal, obviously not equal, you will add 273. But if I am saying 30 degrees Celsius change of temperature, or I am saying 30 Kelvin change in temperature, both are same because their number of divisions is same. So on the basis of the temperature scales relation, let's see a question. You can say this question is between degree Celsius and Fahrenheit. Y-axis is degrees Celsius, x-axis is Fahrenheit. So we have plotted a graph between degrees Celsius and Fahrenheit, and the graph seems to be a straight line. The question is asking you find the slope of the line AB. Okay, straight line is this. So a standard equation that must be y is equal to mx plus c. This is the standard equation. Fine. Now if you will see the relation, what relation? C minus LFP upon total number of division. Same for F minus LFP, lower fixed point was 32 degree Fahrenheit upon, this was 212 minus 32. So basically C by 100 is equal to F minus 32 upon 180. This is cancelled. This is 5 from 2's table, this is 9. So basically what we are getting here, C, that is y-axis, y is the degree Celsius, is equal to 5F by 9 minus 32 into 5, 160 by 9. This is y equal to mx minus c. C is the intercept, and you can see intercept is below origin, so obviously that is negative. Now if you will compare this with mx plus c, this comparison, we can get that slope m is 5 by 9. So in this way, the graph can be of any temperature scale, Rankine-Reaumur or Kelvin or Celsius Fahrenheit. And by writing the relation, you can see the power of every temperature scale, there is 1. So obviously the graph will be straight line, and we can solve like that. Next point that we have to study in this is the thermometry or thermometers. Thermometers, how to measure temperature. Okay, fine. We have most often general you have used that thermometer in our household applications for checking of the fever and all. So whenever thermometer is inserted and it is withdrawn, it is seen that what we see length of the mercury. What we actually observing there, the length, and what we say after observing length, we say temperature. By observing length, we are saying about temperature. So basically temperature and the length, they are calibrated. Temperature and length are calibrated. That calibration property is used in thermometer. So basically some physical properties of material is calibrated with temperature. What happens in thermometer? Here some physical properties of materials are calibrated with temperature. Some of the known physical properties, what are the physical properties are? Some of the known physical properties are, we can say, length of the solid. length of the solid, and that we have used where? That we generally use in mercury thermometer. Second physical property that is used in thermometer is pressure of gas. Pressure of gas, where? At constant volume. Pressure of gas at constant volume. Next, this is called constant volume gas thermometer, because this is pressure of gas that we use as the physical property. Next is volume of gas. You know that pressure, volume, they vary with temperature. They can be calibrated, and according to temperature, when they vary, we can measure. We will observe pressure, we will observe volume, but we can measure temperature as they are calibrated. Volume of gas at constant pressure. Next, electrical resistance. We know that resistance and resistivity, they change with temperature. So these are the commonly used, we can say, the physical properties that are calibrated with temperature, and when these property changes, accordingly we can calculate the change of temperature. So if we will consider them like all the physical property, here I am saying all the physical property, let's all the physical properties x. Okay, so when x is at T degrees Celsius and when x is at 0 degrees Celsius, what is the difference of temperature T? So difference in physical property per unit temperature change. X naught is the physical property at 0 degrees Celsius. There we have calibrated that. Suppose mercury in mercury thermometer at minimum temperature, that is 0.05 millimeter. So that length of mercury is called x, and that x will be different at different temperatures. So we have assumed that x naught is the physical property at 0 degrees Celsius, xt is the physical property at T degrees Celsius. So what is the per unit change? Xt minus x naught by T. Similarly, when you will say x100 minus x naught, what is the temperature change? 100. What is x 100? Physical property at 100 degrees Celsius. So in each of these thermometer, whether length thermometer or constant volume gas thermometer or resistance thermometer, in each thermometer this quantity remains constant. Even this quantity remains constant in faulty thermometer as well. So from here we can actually calculate T, and that T can be written as xt minus x naught upon x100 minus x naught into 100. So this we can say is the temperature calibration. From this we can calculate temperature, like in mercury thermometer, x naught and x100 are calibrated, and we will keep on changing length at every temperature, okay, length changing, or we will keep temperature change and we will see the length changing. So basically length xt and T temperature are calibrated. If you know the value of length or physical property, you can calculate temperature. If you know the value of temperature, you can calculate length or physical property. But do remember this formula, this equation T0 and 100 0, this is valid for even faulty thermometers also. So now let's see a question on that thermometer measurement. Melting point of a thermometer is 20 degrees Celsius. Obviously this is a faulty thermometer, it should be 0 degrees Celsius. 150 in place of 100. Okay, so in this thermometer a temperature is required in place of 60 degrees Celsius, means in Celsius temperature is 60. So what is that temperature will be if you will use this thermometer to measure the temperature? So in this thermometer consider the temperature as x. What is the lower one? 20. And what is the total division? Obviously 130. In Celsius temperature is 60. What is the lower? 0. What is the gap? 100. From here, when you will calculate x, that is 13, 6, this is cancelled, 1 0, this will be cancelled. This is 78 plus 20 and your answer will be 98 degrees Celsius. So basically this is, we cannot say Celsius, this is Celsius dash. It should be like, or you can say, or faulty Celsius. So one is the accurate Celsius, that is 60 degrees Celsius, one is the faulty Celsius. But you have noticed one thing, that formula of thermometer is valid in faulty as well as in accurate everywhere. Now we will see modern thermometry. What is modern thermometry? See, in classical thermometry, what was the problem? Two fixed point theory was there. Temperature BP, temperature MP, but what was not included was the pressure. According to them, every temperature change, I mean if your heat supplying is there, temperature is changing, this entire process is taking place at constant pressure. Pressure has no effect on temperature, but we know this is not the case. So we can change the state also, like boiling point is not only responsible, temperature is not only responsible for the state change, pressure is equally responsible. So we had to include pressure also. But pressure in classical physics was not included. That's why the two fixed point theory, LFE, UFE, that was changed to one fixed point theory. There's a question in NCERT, why two fixed point theory was changed? And the question is because pressure was not taken, pressure was not considered as the factor responsible for the state change. So in modern thermometry, there is one fixed point only. And that one fixed point is called triple point of water. This is triple point of water, and this triple point is 6 mm of mercury approximately, not accurately, 6 mm of mercury. This is called triple point pressure, and triple point temperature is 0.01 degrees Celsius, which is 273.16 Kelvin. So in this situation, if you know the physical property at a temperature, X is the physical property, that is the length or the pressure or the volume or the resistance. This is the physical property at a temperature, and that temperature is T. So what we do, we calibrate a physical property at triple point. So that X physical property is already calibrated at triple point. So triple point temperature is known, and at triple point that physical property is known. When temperature will increase, accordingly that physical property will also increase. So if you have some physical properties other than triple point, then you can calculate the corresponding temperature. This formula is used for thermometer in modern thermometry. So this was the basic discussion of thermometry. Revise all the points, and do remember this is a fundamental, basic, but equally very important. And be prepared, NEET is coming. Be ready to get 180 out of 180 in physics and 720 out of 720 in NEET. God bless you. Take care.